Well, hello again. We are back working our way through the CAASPP Math 8 Practice Test. Hopefully you got to watch the first video where we worked through the first 5 problems. Now we're going to go ahead and work through questions numbers 6 through 10. All right, so here we go. So it says consider the line on the graph. Enter the equation in the form y equals mx, where m is the slope. All right, so as we take a look at this line on the graph, hopefully you notice a couple things. It goes through 0, 0, and it is a line, which means it is linear. And those of you who are paying attention, which is hopefully all of you, know that if you have a line that goes through 0, 0, it is, that's right, ladies and gentlemen, it is proportional. And proportional equations can be written in the form y equals kx, where k is equal to y divided by x. And remember, k is called the constant of proportionality. Just going to put constant of prop. So if we take a look at this equation, there are several points on this line that we can look at. For example, this one right here. Now remember, when we write an ordered pair, we put x first and then y. So this point is 10, 5. Let's skip over to this point right here. This point is 30, 15. And how about this point way over here? It is 70, 35. And if I were to ask you, how do the y values compare to the x values? Or what is y divided by x? Because that will give us k. So if I did this one, for example, I would go 35 over 70. And 35 over 70 is 1/2. What about if I did this other point over here? 15 over 30. Guess what? It is also 1/2. 5 over 10 is also going to be 1/2. So k is equal to 1/2. Now, if you look at the way they asked us to write it, they asked us to write it y equals mx, where m is the slope. But in a proportional relationship, m is the same as k. If you don't believe me, slope is equal to, do you remember, rise over run, right? Or change in y over change in x. So if we go ahead and take a look at this line right here, if we choose any 2 points on the line, because we can choose any 2 points on the line, it goes up 1 and over 1, right? Up 1 and over 1. After going, oh, Mr. Reeves, you were wrong. The slope is not 1/2, it's 1. You have to look at the scale. Going up 1 is not actually going up 1 at all. It's going up 5. And going over 1 is not going over 1 at all. It's going over 10. So we actually get a rise of 5 and a run of 10. And guess what? 5 over 10 simplifies to 1/2. So the equation that we are looking for is y equals 1/2 x. So we're going to go down here and we're going to go ahead and use our keyboard and type in y. I think we're going to use our keyboard and type in y and then equals. Now I need to do 1/2. So if I look here, there's the fraction right there. And on top, I'm going to put a 1, and on the bottom, I'm going to put a 2. And then I'm going to go ahead and use my keyboard again and type in x. So y equals 1/2 x. The y value for every point on that line is half of the x value. All right, let's go ahead and go to the next question. Ooh, scary. All right, an expression is shown. J squared times inside parentheses k to the 6th divided by k to the 4th times k to the 3rd, all raised to the negative 3 power. And it says Martha evaluates the expressions using these steps. It shows the steps. Martha made a mistake. In which step did Martha make a mistake? And what is a correct expression for that step? All right, well, before we dive into this problem, let's think about what we need to know if we're going to evaluate what Martha did. All right, so I believe we did a problem earlier with exponents. First of all, x to the a times x to the b, I believe we did this in a problem, is x to the a plus b. So when the bases are the same and you are completing a multiplication problem, you add the exponents. All right, what about if we have x to the a raised to the b power? You notice now we just have that one base and we have the two powers. And in that case, we don't add, we multiply. And we get x to the a times b. All right. Whoa. Let's try that again. Here we go. All right, now what about a division problem? What about x to the a divided by x to the b? Do you remember what to do on that one? It's x to the, well, if we add in a multiplication problem, and multiplication and division are opposite, guess what we do in a division problem? That's right, we subtract. So x to the a divided by x to the b is x to the a minus b. All right, so those are the rules we need to know. This is called the product power. This is called a power. This is called yeah, the product property of powers. This is raising a power to a power. And this is the quotient property of powers. All right, so let's take a look at what Martha did. So it looks like she started inside the parentheses here. So if we start inside the parentheses here, on the top is k to the 6th, and on the bottom is k to the 7th. So what did she do? She took k to the 3rd times k to the 4th, and she made that k to the 7th. Is that correct? K to the 4th times k to the 3rd is k to the 7th. Well, that is this right here. So ladies and gentlemen, that step is okay. We're good on that one. All right, now let's take a look at what is next. Now we have k to the 6th over k to the 7th, and when she was done, she had k to the negative 1. Well, what did we say that we do in a quotient problem? We subtract. So k to the 6th over k to the 7th should be k to the 6 minus 7. And what is 6 minus 7? It is negative 1. So guess what, ladies and gentlemen? That step is also okay. All right, now let's take a look at step number 3. Well, if you take a look here, what did she do? She took this part right here and she simplified it to that, because as you can see right here, these two parts are the same. In fact, those are the same straight down, right? So to get from there to there, what did she say? She said k to the -1 to the -3 power equals k to the -4 power. Well, what did Martha do? She did what with these two numbers? How do you get -4 from -1 and -3? You get them by what? Adding, right? But what does the power property say that we need to do? Raising a power to a power, you don't add, you multiply. So ladies and gentlemen, this one is not okay because she added instead of multiplying. So what should it have been? What should k to the -1 to the -3rd power be? What do you get when you multiply these two together? What is a -1 times a -3? Well, a negative times a negative is a positive. So it should have been j squared, right? Because that yellow part there hasn't gone anywhere. J squared times k to the +3. All right, so the mistake was in what step? The mistake was in step number 3. And what should the answer have been? J squared k to the 3rd. Step 3, j squared k to the 3rd. And there's our answer. And that completes question number 7. All right, moving on now to question number 8. Here we go. The graph shows a proportional relationship. We know that because it's a straight line that goes through the origin. On the distance traveled, between the distance traveled by Tim on a road trip and the number of hours for which he traveled. So here we go. So his distance is y and the number of hours is x. And remember, in a proportional relationship, y is equal to k times x, or k, the constant of proportionality, is equal to y divided by x. K is equal to y divided by x. All right, so I'm not going to go through the choices yet. Let's just get this information down so we know what's going on here. And I always like to write these as ordered pairs. So our first ordered pair is 1, 50. And then we have 2, 100. And then 3, 150. 4, 200. And 5, 250. So if I were to ask you, what are we doing to these x's to get the y's? Or what is the y divided by x each time? And again, we can use any point because it's a proportional relationship. So what is 250 divided by 5? Well, that's the same as 200 divided by 4, or 150 divided by 3, or 100 divided by 2, or 50 divided by 1. They're all the same thing. They all equal 50. So what do we know? We know that k is equal to 50. In other words, the distance is equal to the number of hours times 50. And the slope of this line, remember, we did this on the previous problem, y equals kx. That's the same as y equals mx. M, the slope, is equal to k, the constant of proportionality. All right, so k is 50, so that means m is 50. So that means that the distance is 50 times the number of hours. So what does that mean about his speed? What does that mean? His speed is 50 miles per hour. All right, so if we look at the choices, let's take a look. Which statement identifies the correct slope? We already said it's 50, so that eliminates C and D. And the interpretation is he is going 50 miles every hour. So we're looking for A. If you look, one mile every 50 hours, that would be super duper slow. 1 mile every 50 hours, right? 50 miles every hour. We got it. That answers question number 8. Only 2 more to go. All right, we have finished this section. We're going to go through. Yes, we're good. Question number 9. A leaf falls 18 feet from a branch to the ground at a rate of 5 feet every 2 seconds. 5 feet every 2 seconds. Determine whether each statement is true. Select true or false. So a leaf falls 18 feet from a branch to the ground. So if I were to ask you, is the initial height 18 feet? Initial. Initial is another word for starting. Does this leaf start at 18 feet? Well, it says it falls from a branch to the ground. So I'm going to say yes, that is true. It does start initially 18 feet above the ground. The leaf falls at a rate of 2/5 of a foot every 1 second. All right, so let's take a look at the rate they gave us. They gave us a rate of 5 feet every 2 seconds. All right, now that is a rate, but that is not a unit rate. And the reason it's not a unit rate is because the second part of that ratio, the second part of the rate, is not 1. So if I wanted to change this to a unit rate, I would change 2 seconds down to 1 second. And how do you get from 2 seconds to 1 second? You divide 1 second. 1 second you divide by 2. So to get for a unit rate, I need to divide the seconds by 2. And guess what else I need to divide by 2? I also need to divide the distance by 2. So I get 5 divided by 2 feet. So if you take a look at that, 5 divided by 2 feet over 1 second, is that what this says? It falls 5 halves of a foot, right? This says 2/5 of a foot. Those numbers are reciprocals. So this one would be false. It would be true if it were 5/2, but it's not. All right, the leaf is 3 feet above the ground after 6 seconds. All right, so what did we just say? It falls 5 halves of a foot every second, right? Let me try to do that a little bit neater. 5 halves of a foot every second, right? Okay, well, 5 halves of a foot is the same as 2.5 feet. Yes? Hope you agree with that. All right, and that's every 1 second. So if I want to know how far it falls in 6 seconds, what should I do? I need to take that 2.5, how far it falls in 1 second, and multiply that by 6. So 2.5 times 6. 6 times 5 is 30, carry the 3. 6 times 2 is 18, plus 3 is 21. So according to this, if it falls 2.5 feet every second. In 6 seconds, it will fall. Did I do that right? 6 times 5 is 30. No, something is wrong. 6 times 2, goodness gracious. Mr. Reeves, 6 times 2 is 12 plus 3 is 15. Where did I get 21? 6 times 2 is 12. 12 plus 3 is 15. So it will fall 15 feet in 6 seconds. That's better. All right. How high did it start? Started at 18. How far did it fall? Not 21. It fell 15. 18 minus 15 is 3. So at 6 seconds, it will have 3 feet left to reach the ground. And that, ladies and gentlemen, is what it says. So it will be true. So we are looking for true, false, true. I apologize for that math error. Glad that you guys caught it for me. All right, number 10, last question for this video. Here we go. Sally is solving the linear equation 13 plus 4x minus 9 equals 7x plus 7 minus 3x. Those are her final 2 steps that they gave. Select the statement that correctly interprets Sally's solution. All right, so it doesn't ask us to say whether Sally did it correct or not. So a quick check shows that she did, because here's our 4x and there's our 4x. What is 13 minus 9? 13 minus 9 is 4. So she simplified this side correctly. 7x, right? 7x minus 3x is 4x. 4x plus 7. So she gets 4 equals 7, because they didn't show the work. But if I have 4x plus 4, I just switch these two around, equals 4x plus 7. If I take away 4x from each side, I get 4 equals 7. So I got the same thing that Sally did. The question is, what does this mean? And they give us some answers. All right, so does it mean that x is 0? Now, just a reminder, and I've said this over and over and over again in class, solving an equation is finding the value of the variable that makes the equation true. So if the solution is x equals 0, then what we are saying is we can put 0 in there, and the two sides should be equal. Well, since this is the simplified part, let's do it right here. What happens when you multiply 4 times 0? It goes away, and that goes away. Does 4 equal 7? The answer to that is, of course, no. So it does not mean that x is 0. X is 0 does not make the equation true. Does it mean that the solution is the ordered pair 4, 7? Well, guess what, ladies and gentlemen? In an ordered pair, you have x and you have y. If a solution is 4, 7, that means x is 4 and y is 7. Guess what we don't even have here? We don't even have a y. So that it is not going to be the second one. So this one is no. This one is no. There is no solution since 4 equals 7 is a false statement. Let's hold off on this one and let's look at this one. There are infinitely many solutions since 4 equals 7 is a false statement. If there are infinitely many solutions, that implies there are many, 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 many ways to make this true. All right? But let's think about this. When does 4x equal 4x? The answer is always. Pick any value of x and those two are always the same. So no matter what x is, this part of the equation will always be true. Now let me ask you a second question. When does 4 equal 7? And the answer is never. So the pink part will always equal the pink part, but the green part will never equal the green part. So what does that tell us? It doesn't matter what we put in for x. Those two will always be true, but the other parts will never be true. What this says when you get the answer is this equation will be true when 4 equals 7. And ladies and gentlemen, that is never true. This has no solution. Not infinitely many. It has none. It will never be true. So we answered the question. Just a quick add-on though. If we had gotten instead 7 equals 7, say that had turned out to be 7, then the answer would have been there are infinitely many solutions, because then both parts of the equation would have been equal to each other always, but they're not. So when you solve an equation and the variable terms go away and you're left with a statement that's never true, it will have no solution. If you're left with a statement that's always true, it will have infinitely many solutions. But for us, there is no solution because it is a false statement. And that takes us to question number 11, which we are not going to do. We'll do that in the next video.